I'm gonna talk about Python3 support in GRUB2. I won't introduce myself again, so I'll just skip. Problem statement. Currently, all firmware validation systems run on top of some operating system, because operating system provides some API, etc., and it's more sophisticated to support various test cases and software implementations. But on the other hand, operating system may also introduce some point of failures. Like if we want to validate firmware, we should probably validate it on the firmware level, not on the operating system level. There are a few implementations of the firmware validation, but for example, some of them require Python, like bits and chipsec. Chipsec, for example, also runs on top of operating system, as far as I know. FWTS or LAV, which is Linux UEFI validation, a mix of bits and chipsec, and FWTS probably. Yes, and how about existing solutions? So FirmDep had once a request for some validation payload implementation, and what we did was to integrate bits which run on top of GRUB2 with Python support compiled in. Other efforts we have heard about were, for example, MicroPython support in UEFI, for example, for some chipsec operation. Chipsec was also meant to migrate to MicroPython. And yes, and FreeMDep also did some bits and chipsec as core boot payloads. And as far as we know, currently upstream graph have no support of Python at all. So who should care? Typically, there is very little firmware validation. Right now, firmware and BIOS developers are not paying enough attention to validate. Just we launch, we perform some basic checks if it works okay, and let the others report bugs. Yeah. So we would like to have some more sophisticated validation system. And yeah, there are some customers that would like to have some compact validation, which is not dependent on the operating system, and would like, for example, to have some compact implementation that can be put inside this PyFlash. We often see some OM implementations in UEFI, like they'll have some diagnostics implementations inside their UEFI systems, which run some generic tests over storages, fan control, etc., etc. And there is also a use case where some systems require certification. So this validation payloads, for example, could play a role that would validate every crucial point in the system which require this certification, like, for example, some certain fixed MP table contents or SMBIOS compliance, for example, etc., etc. The business cases. So, sure, please.
Okay. So, just to explain a little bit more about business case of this Python supporting GRUB or something similar. So first of all, deeply embedded systems and high-performing applications are rely on some precise hardware initialization. So let's say we need some interrupts configuration, some correct ACPI tables, and we hope that that our hardware is tuned to our needs, and typically applications should not do anything with that, which it should just start and use hardware, and don't care about reconfiguring and keep watching hardware if it behaves as it should. Then this embedded application may use some interfaces to firmware, like UEFI runtime services, some ACPI stuff. It may rely on MP tables. It may rely on SMBIOS tables. And because of that, we have all these dependencies. We should also make sure that those things do not change, or at least do not change in a way that affect the application. That's a very important thing from business perspective. And because of that, some customers that we faced or some people that we talk with had this idea of kind of verifying that. So maybe one off-topic story. So let's say like I'm getting hardware, offshore hardware, yeah, with some offshore BIOS. Like I don't develop BIOS. The person who sell hardware give me also the BIOS with the platform. I cannot sell safety critical application like fully relying and trusting that party, because anything can change. They may change something small on the motherboard. The BOM may change. There may be some adjustments in the firmware itself, and then suddenly my application, I'm flashing my application, doing basic checks, and shipping to customers. This may cause serious and dangerous situations. So because of that, some customers decided that they want to have like a very small so-called validation payload or some small thin application that quickly on manufacturing floor gives the feedback what's the quality of underlying hardware and firmware. And if the configuration of that is acceptable. This may also make sense in security area. If system complies to security measures that we expect. So it works like that we have this small software and on manufacturing floor where we putting together our final application. We're getting some board, which is kind of component of this bigger application. We flash quickly this validation payload. We run it. We have results. If everything is fine, we leave everything else and we just replace the validation payload with target application. Yeah, and thanks to that, we have like at least some confirmation that our application will behave the same across all the shipped products, and that's the business case behind this problem. And it looks because of like there's a lot of work already done in Python, for example, for validation, and it seems to be language of choice for validation frameworks or firmware validation frameworks. It would be great if we can quickly in bootloader run this validation scripts and get the results without booting whole ecosystem, which to be honest may make things not so clear, because there is another layer which can kind of hide some things and like change the results of the tests. So we want like almost bare metal validation system for embedded applications.
Okay, so to be continued, what really is needed to have this Python3 support inside GRUB? So we need to have a Python3 compilation support for GRUB2. Python2 would also work if not the deprecation, which soon will come. The various Python libraries may also be some dependencies for certain validation frameworks like BITS or ChipSec. And there should be some operating system helpers, so-called operating system helpers, that, for example, provide some POSIX operations for BITS and ChipSec, like is this a directory or something like that. The state of the various components we have been facing here is like as follows. So BITS currently we're using a custom Python2 support. They maintain their own fork with some changes. They were also keeping a fork of GRUB2, which had certain modifications and have rolled back some deprecated changes. Like I will explain them in a while. And yeah, for quite a long time it is no longer maintained, and there was no contribution at all. GRUB2 currently has no Python3 support or Python3 interpreter, so yeah, we should have some implementation of integration of the Python3 and the interpreter. And yeah, GRUB2 can be also used as a CORD boot payload, so it's also helpful. When it comes to chipsec, it requires some helper functions from OS or bits itself, like I mentioned earlier. Of course, some of the operations will not be available due to requirements of the GRUB environment, and GRUB is not OS, of course. And yeah, chipsec is now very focused on UEFI, so not all tests could be executed, but we can live with that. And another major disadvantage is that chipsec runs on Intel Silicon only for now. So what should be done to achieve the goal is to port the Python building and integration from bits to GRUB2. Use Python3 source code instead of the Python2, which will be soon deprecated, and re-add a couple of functions to GRUB2. For example, like group string cat. Disable support for software floating point arithmetics using combiner flags. It was some dirty hack that just allowed to build them, the binary. And yeah, bits need to understand paths, so it is crucial for certain use cases in bits. For example, isDirectory function needs some fixing, because when we run from SpyFlash, we have no file system at all, in the means of a real file system on the disk. So how example architecture looked alike with which we developed here in FrameDep is that we copied some chipsec source code into bits environment, which held all the test cases written in Python, with all the support for ACPI parsing, SMBIOS parsing, and other stuff. There were other components like some runtime libraries which are required for certain components like CPython and etc. There was also some environment stuff like the GRUB2 I believe, which was able to run the Python interpreter. And yeah, we also had GRUB contrib.deps, which were building into a boot config in the GRUB. So all these components were packed into a mem disk, which was there launched by the GRUB automatically, and contain this Python test scripts and runtime libraries were compiled into Python module itself, the mem disk. And everything was then packed inside the core boot firmware range on the SpyFlash. So open questions is as follows. Does the adoption of Python interpreter make sense in light of dependencies of other various modules? And if do GRUB2 even care about the Python support in the bootloader? So to sum up things, we know that the operating system is an external customer to the firmware, and it may do some things on its own, and may, in such case, introduce another point of failures for those firmware validation systems. And we should avoid to validate the firmware in the OS level. And the build system of the bits and chipsec as payload is not so friendly, because when we utilize, for example, the SpyFlash as a medium, we have to reflash it each time we modify some test, or if you want to add something. And yeah, due to the many components it consists of, there are many also tools that need to be considered during the build. So most preferable build system is Docker in most cases. And yeah, currently we practically have no pre-OS validation suite available that would support, for example, so open source firmware projects. Mostly these are some proprietary or UEFI implementations, and yeah, and except bits, nothing is really maintained at all.